students, and welcome to today's lesson. I'm Mrs. Doble. Today, we will continue to explore the question, how does energy move through an ecosystem? Are you ready? Grab your pencil and your science journal, and let's get started. Imagine you are in a cabin high in the mountains. It's cold outside, and the ground is covered in snow. But you don't mind. You're all snug inside next to a fireplace. The logs are burning brightly. You hear the flames crackle and see sparks fly. You can feel the heat from the fire on your skin. But how do the logs create heat? Well, logs come from trees, like a mangrove tree or another tree. And trees are plants. Our radish plant investigation taught us that plants need sunlight to store energy and grow. Without sunlight, plants can't survive. What about the mangrove tree? Do you think the mangrove tree stores energy like the radish plants? Do you think it provides energy for other organisms in the mangrove tree ecosystem? Let's read a passage from our book, The Mangrove Tree, to look for answers to our questions. As we read, listen closely for evidence of energy in the mangrove tree ecosystem. Now, the people of Hargeiko use every part of the mangrove tree. Bundles of dry branches are fuel for the fires that cook food for the mothers and fathers and children. There is more meat to cook and more milk to drink because the families own more animals. The children are healthier. Wow! What did we find out? What evidence does this passage offer to indicate that mangrove trees have energy? The story said that the branches are used to fuel fires. Fires give off light and heat. Do you remember the indicators of energy? Can you name them? Light, motion, temperature change, and sound. Burning wood from trees gives off light and heat. So, do you think that wood has energy stored in it? I think so too. The mangrove tree must have energy stored in it, but where does this energy come from? Did you say the sun? If so, great work. The mangrove tree, like all plants, stores energy from the sun in its plant tissue. Let's add the sun to our anchor model. In this lesson, we want to understand how energy flows through an ecosystem. So let's add an arrow to show that energy flows from the sun to the mangrove tree. I wonder, does the energy stored in the mangrove tree flow to other organisms in the mangrove tree ecosystem? The book mentions that people make fires with branches from the mangrove trees to cook their food. Those people definitely use the stored energy. But people aren't the only organisms in the ecosystem. Do animals get energy from the mangrove tree? Yes, animals are consumers that get energy from eating the leaves of the mangrove trees. And because those animals get energy from the mangrove tree, people can get more energy from food. People have more meat to eat and milk to drink. Wow, it seems like energy is a very important part of the mangrove tree ecosystem. Let's highlight the arrows that show the flow of energy. What about the aquatic plants and animals? Do aquatic plants get energy from the sun? Yes, and the aquatic plants provide energy to the aquatic animals that eat them. Let's highlight our arrows that we first drew to show matter to now show the flow of energy among the aquatic plants and animals. What about decomposers? We know decomposers break down dead organisms and use the matter from those dead organisms to grow. If decomposers can get matter from plant and animal tissues, then they can get energy from those tissues too. Let's highlight our arrow to show this energy flow. When we first drew our anchor model, we drew a food web. Then we realized that the arrows show how matter flows from producers to consumers and decomposers. Today, we highlighted these arrows to show that they also show the flow of energy. So the arrows in our anchor model now show how energy flows from the sun to producers and then to consumers and decomposers. We need to update our anchor model description as well. Let's add, plants use energy from sunlight to transform the matter in air and water into new plant tissue. Some of this energy is stored in the plant's tissues. The energy is transferred to animals that eat plants and then to animals that eat other animals. We also have enough new information to update our anchor chart. In fact, I think we need to add a new section. Let's add the heading, Life's Energy, and write, plants capture energy from the sun and use it to make food and form new tissue. Animals get energy from food. Animals use energy for growth, body repair, and movement, and to maintain body warmth. Energy flows through an ecosystem from the sun to plants and then to animals and decomposers. Wow, our mangrove tree ecosystem is much more complex than we thought at first. Each organism in the ecosystem depends on other living things. The health of the ecosystem as a whole depends on these interactions. What might happen if we removed one of the organisms from the anchor model? Or if we add a new organism to the anchor model? Could that be good or bad for the ecosystem? I can't wait to find out, can you? Let's review your tasks for today. First, update the anchor model and explanation. Next, fill in the blanks to update the anchor chart.